Okay, so let's talk about the leading coefficient test for polynomials. So we discussed with polynomials that they are continuous and they also continue without bounds, meaning like as you continue to graph the polynomials, they're either going to continue rising as you move to the right or falling, or they're going to continue rising or falling as you move to the left. And that is what we basically call our end behavior. And we can use the leading coefficient test to determine the end behavior without actually having to graph the polynomial function or without even knowing what the polynomial function looks like. So when we're looking at the using the leading coefficient test, there's a couple things that we want to make sure that we have. First of all, we want to make sure we put the polynomial in standard form, meaning that we have the degree, which is the largest power, first, and then all the rest of the powers in descending form. That's what we call our standard form. We also want to make sure we can identify the degree of the polynomial and determine if that degree is even or odd, and then determine the leading coefficient from the leading term and determine if that is positive or negative. Now, rather than trying to memorize all this information that I have here, I prefer just to kind of visually understand and represent all of this information. And that's the way that I memorize it. I mean, you might be able to memorize this and feel good and feel better. That's fine. I'm going to show you kind of visual representation the way that I memorize stuff. Now, also, I wrote everything in a very non-mathematical kind of, not really way, but not like a very standard way to writing the end behavior. And we can talk about end behavior using limits. We can just talk about it, very conversationally like this. And then we can also use another notation, which I'll talk about, which I'll primarily be using in my class. Now, let's just kind of look at understanding this because I don't really like memorizing, stuff in class or having my students have to memorize anything. So the way that I understand the way that I memorize the leading coefficient test is just to kind of look at things in quadrants. So we look at the columns as our degrees. And our degrees can be broken up into, let's move this in here. Our degrees can be broken up into either an even degree or an odd degree. Then we can talk about, then the other thing we look at that's important is the leading coefficient. And the leading coefficient we either want to be positive or we want that leading coefficient to be negative. Okay. Now, I need to kind of understand what's going on if I have an even degree and a positive leading coefficient. And the best example that I know of for that would be a quadratic, like x squared, right? A positive x squared, we know that's like the U-shaped graph. So I'm just going to like draw a sketch there of the U-shaped graph. And what I can see here is that when it is even and positive, the graph rises to the right and left, right? Okay. And then if I put like a negative x squared there, well, I know that for my study in quadratics, that's just going to flip it, right? So it's going to look something like this. Now it's going to fall to the left and fall to the right. So as you can see here, if it's even negative, the graph falls to the right and left, right? So that's pretty easy for me to remember. And again, this doesn't matter if it's x to the 4th, x to the 6th, x to the 8th, x to the 12th. Anytime you have an even power, your polynomial is going to take the same end behavior as x squared. It's going to either rise to the left and right or fall to the left and right. And that is dependent on the leading coefficient being positive or negative. Now let's kind of switch over to the odd powers. If it is odd, if it is degree is odd and the leading coefficient is positive, what is that shape? Well, the best function that I like to remember is just the identity function, x. What the graph looks like that's just a nice little line. And you can see here when the degree is odd but the leading coefficient is positive, the graph rises to the right and falls to the left, which is exactly what I have here. Remember, there has a degree of 1. Now again, that doesn't matter. It doesn't matter even if it's like x cubed. Look at the x cubed function, which is another one of our parent functions we talked about. Notice that's like the little S-curve graph. You can see it rises to the right and falls to the left. The only time this is going to be different now is when this is negative. And remember, negative is like flipping it over the x-axis. So now the graph is going to look something like that. And you can see, now this is not the x-y axis. Just be sure. But the graph rises to the left and falls to the right. So you can see that's going there. Now, let's actually look at each one of these graphs and describe this because this notation is fine. And for my directions, I will basically do that for time purposes. I'm going to kind of represent that. But I also want to kind of represent here, kind of looking at this in another scenario. So if we were going to look at this, so here, let's take about this quadratic here. So, here's a quadratic function. Okay, here's the x-axis, and here is the y-axis, or what we could also say f of x, right? Same thing as y, which is really the same thing of f of x, depending on what notation we're using. So when we're trying to describe the end behavior, I'm not going to talk about the limit notation for this. We'll talk about that later in another chapter. But if I want to describe this using notation that's a little bit more mathematical, not really just conversational, if I say as x approaches infinity, what that means is as my x values, right, as my points on the graph, that the x values of those points on the graph, as they're going towards infinity, that means as they're moving to the right. So I'll just say that basically says moving right. What is happening to my f of x values? So f of x, which is the same thing as my y values, where are my y values going? So as my x values move to the right, my y values, or my f of x values, are going where? They're going up. Or you could say, instead of just saying going up or rising, we could say they are approaching infinity, which is, basically the same thing as, let's just say, rising. So this is just a more mathematical way to write things, and then here's kind of like the conversational piece. If I wanted to say what is x is as x is going to the left, so I'd say as x approaches negative infinity, which is basically just saying moving left. Now again, I'm talking about left and right here because x is going towards infinity, negative infinity, right? X is moving left or right. Then f of x, which would be moving up or down. Well, if in this case though, you can see my f of x values or my y values are going up. So therefore it's going to be approaching infinity, which is just going to be the same thing as like rising. Okay, so when I get into my example videos, which we're going to get into next, I will mix in that notation just so you can kind of see it, so you can kind of see the difference. But probably for time purposes, I am going to, stick with this understanding just so you make sure that, we can cover the whole video and not take so long. So now that hopefully you have a little bit of a better idea on the leading coefficient test, it's time to go ahead and get started with some examples.